SF State's program in visual impairments presents TechTalk number 8, Accessible Digital Math Workflows for Blind and Low Vision Students. Presented by Neal McKenzie, Assistive Technology Specialist, Sonoma County Office of Education VI Program, Shawn Jordison, Assistive Technology and Alternate Media Specialist, CCC Accessibility Center.
And there have been some, even in our department, some hurried but great ways that we have found to make sure our students have access to math, which has always been a struggle. And we're still not 100% there, but we have found some things that have worked extremely well. So the first workflow that it really has saved our teachers, our braillists, myself, so much time is creating accessible math documents. And the specific workflow that I'm going to go through right now is using 3 different aspects. We're going to use Equatio, and we'll go through that. Equatio connected with Word, and then we've really found great success in our students who are using a note taker. Specifically, this workflow would be perfect for a student who's using the Braille Sense Polaris. And it really is a great way because on top of this, you can build an environment that in real time is accessible. And we'll talk more about why that's important, especially for the classroom teacher. So first, we will go through the aspects of this workflow in creating a document that can not only be visually seen, but also have the Braille on the freshable Braille display of a Polaris, have the Nemeth right there at the student's fingertips in the same time that you're looking at a print document. So I will go ahead and share my screen. All right, so at first we've gone through this every different way, and that's really why we've developed this workflow, just because we were doing so much of it, I'm sure as most of you are too. So what we're going to use, and I have a list of links too that I'll give to Ting that she can post, and it has a link directly to Equatio. And as teachers, there's a free account that has most of the premium benefits to it. I've never had to use anything other than the free account for teachers. So that will be available to you at the end. Okay, so what's nice about Equatio is it's free. That's always nice. And it can be used on the Mac OS or the Windows OS. And what you get is this toolbar. And really the magic bullet with this toolbar is this screenshot reader. Now what this screenshot reader does is it will take any image of a math equation. That's why I chose to use a PDF, because this is actually a math sheet that I did last week. So I thought this would be perfect. And what it does is when you take that snapshot, let's see if I got that all. Okay, so once you take that,
2i plus 6i.
Not only will it give you the verbal or the audio of the equation, but here's where the magic is. If you go down to edit in Equatio, the problem is right there. Now you have a Microsoft Word document open. And actually, let me start exactly how I would do this. Let's start from the beginning. So this was a math sheet I got last week. So simply I would take anything that I needed to copy, that I can copy directly onto it. That's not a math equation. And I would start there. So now we have our first equation. So take that snapshot.
I plus 6i.
Not only do I get the audio of it, but then I edit in Equatio, and it's right here. Now there's 2 ways that I can get this right into the Word document. I can either press this button, insert math, or I can press Control Option Enter and have it automatically put it into the document. Either way, whatever one's fastest. And simply after I insert the equation, I put my numbering, And the magic is, I don't know how this works behind the scenes, but any equation that's created with the equation editor in Microsoft Word will provide the student with the Nemeth translation, as well as the visual print when looking at a digital math sheet. And so all this does is just save you the time of inputting it through the actual math equation or using something like Mathtype. So it saves quite a bit of time. So I'm going to do the first 3 problems here, show that process again. And again, edit in Equatio, insert math, and then I'll show you, I'll explain too why I'm formatting it in this way too. Label my problem, and we'll do one more. We're going to take that snapshot.
-1 minus 8I minus open paren
Edit
4
in
minus.
Equatio, insert the math, and then number it. And what's great about this is it takes very little time to compile a complete math sheet. And the reason that I'm formatting it like this, and again, I don't know how this works behind scenes, but we've tested this quite a bit of times, and spacing, having a space before and after each equation somehow makes the environment a lot less buggy. We've tried it both ways, and again, I don't know how that works. I don't know why that is, but having a space between those equations is key to having it really seamless and not have all those bugs pop up or having them get kicked out of the program. So once I've compiled this, what's great about it is that I can send it to the student, and the student can have the Nemeth and the Braille underneath their fingers. But then also, if I send it to the Polaris and then remotely connect using TeamViewer, then I'm looking at this while the student has the Nemeth coming up. Now, what is so beneficial about this to having both parts is that at that point, you can make the connection between the classroom teacher and the student. And eventually, if you have that kind of communication and you kind of have that team mentality in the classroom, you can start phasing yourself out to where that connection is made by the classroom teacher and the student. And then that way, just direct content is what they're worrying about, as opposed to the access or the technology. So we have started spending more time training the classroom teachers on how to create these documents for our students who use this particular workflow. And what we have found is in the beginning, we've had to jump in on the Zooms and take them through the tech, take them through making a TeamViewer account, connecting with the student, and producing a document in Word, which all the teachers have that's accessible. But what we have found that once they understand that and get that process, then really it's, besides making the tactile graphics or something more complicated, then it really is just the student and the classroom teacher. And we don't have to try to skip around the game of, or feeling that we need to reteach the content, which sometimes you get in that trap because of being behind or because of not having a direct link to the classroom teacher and the student. So we have found this to be hugely beneficial for that. And in teaching this to the general ed teacher in the classroom, so sometimes they need help and they need reminders, but it's gone pretty smoothly. We've done this with 3 classrooms so far, and it's gone great. And this is something that we're going to continue to do even far beyond remote teaching, because it's such a accessible way for each person involved. So now, since we have Equatio up, and then also too in the notes page that I'll give to Ting, it has the links to for TeamViewer and that process too, how to connect to a note taker. And all the note takers connect using a program called Quick Support. So what's awesome about that is that you can see visually the output from the note taker. And again, that's something great to train the classroom teacher on. So they have direct access to the student again, taking yourself out of that equation so the content could be worried about instead of the technology or having another person in the loop when there really doesn't need to be one. So, and again, those are both free, completely free programs. Another thing, since we have access to this screenshot reader, I will show you a real quick way to make reference graphs that are accessible. So again, I'm using examples that these are real examples in the field. Again, this was something I was given last week. So we have a document called Graphs of Rational Functions, Domains, Ranges, and Rational Functions. So we have this equation here, and we also have a graph in print. So the student needs to basically find basic shapes and just find very little information on this. But still, they would need to be able to identify the parts of that graph. So what we can do here is we can, again, use that snapshot tool. And this time, instead of editing in Equatio, we're going to go ahead and copy the LaTex.
F of x equals the fraction with the numerator x plus 1 and denominator
then we're
x.
use Desmos, which most of you are familiar with. It's a free graphing calculator, and it really has accessibility built into it. The creators of Desmos are really passionate about making things accessible. And we're going to talk about how a student can do this on their own too, after we demonstrate this. So now that we have that equation copied, we can simply paste it. And then here it is visually on the screen, the exact same one that was on the page. Now, I don't know if many people know, but you can actually output a Bosser ready graph from Desmos. So if we go here to share graph, and this is where it's a little bit confusing because I think most people would think it would be right under print. But if you go to export image, and again, this part can be confusing too, but under sizes, if you go all the way to the bottom, there's a little area called tactile graphics embossers. And so it has a VP Max 8.5 by 11 inch paper, VP Max 8.5 or 8.5 by 11 inch, the tractor feed, and then the same sizes for the Romeo and the Juliet. Now you don't have to just have these embossers, but I have tried this on 3 different embossers, and I was able to do it as long as I had the right size paper. So if ours is tractor feed 11.5 by 11. So if you click on that, it automatically transforms that graph into a Bosser ready image. And you have the capability of doing Nemeth or UEB, which really just moves those braille dots down and up. So once we have that, we have 2 options for output. Now this is great. And this is something that I only learned once I actually went to the embosser side of it and completed this. So you have download braille equations and you have download PNG. So download braille equations, this is great. So let's say you had multiple equations, or even if you just had one, what that is going to do is going to give you a PRN file, which you can emboss, and it will say expression list, and then it will have that expression in Nemeth on one whole page. And if you had multiple, it would give you that list. Now, the PNG is where the graphic is. So once you download the PNG, then you're able to simply right click, select the embosser that you have on your computer, and it will emboss. Now, the reason that we were so interested in this workflow is we have a student that's highly motivated to emboss their own graphs, to be able to choose what references they need. And even just on a realistic timeline, we are doing our best to maintain our tactile graphs and math in a timely manner. But with this pandemic, and we are on remote teaching until at least December, it's not as fast as it was. We don't have teachers at every school. We don't have teachers going out all around the county. So there's few of us that are trying to distribute these materials. So this student actually came up with this idea, well, why can't I have my own embosser? And it made us think that actually makes a lot of sense. And so we are testing this workflow with the Pixplaster. And that is the first embosser that, well, now there's two, but that is available on quota funds. So we actually have done this workflow completely from start to finish using, which is his setup, which would be NVDA and Windows. And let's see, I think I have a video of that we can show really quick of that workflow.
Hey, Neal, before you start the video, would it be possible to pause for a question?
Yeah.
Okay.
Totally.
So it's a question in the chat. So in the first workflow, you specifically mentioned the student working on a Polaris and having the student access the worksheet there. Is that workflow specific to the Polaris, or would it also work with a Braille Note Touch?
It is specific to the Polaris, but I have a feeling that that won't be the case forever.
Okay, thanks.
Just because it's such a streamlined workflow.
Cool. Thank you.
Was that the question?
Yeah, that was it. We can hope for a harder question later, I guess.
Taskbar. T. Running app, Equatio, Word button, Google Chrome button. New tab, Google Chrome. Address and search D. Desmos.com. D. Search Desmos beautiful. Free math HTTP space. E. Selection removed. Desmos beautiful. Free math. Clickable navigation. Math tool. Resources. About. Login. Sign up link. Language. Main landmark graphing calc. Desmos graphing calculator document. Desmos graphing calculator. Y equals 4 x caret 2 y equals 4x superscript 2 baseline has graph. To audio trace, press Alt plus T. Desmos graphing calculate untitled graph button, share menu button, collapse, expect complementary landmark, copy button, print graph, export image link. Dialog, heading level 1 export your, medium square menu button collapse, link login or link sign up menu button collapse sub, dialog, menu button expanded sub menu medium square, large square button, medium rectangle, large rect, VP max 11.5x11 in, link login or link sign up menu button collapse, dialog, UEB toggle button not pressed. Nemeth toggle button pressed. UEB, accessibility at desmos.com link. Image download grouping download PN, download Braille equations button. Downloading, 0% remaining alert. Download complete, Desmos equations, downloads bar grouping. Space, print PRN file dialog. File name edit Alt plus F selected C. Users can see a downloads Desmos, select file, printer name, copies edit Alt, print button. Download PNG, downloading, 0% remaining alert. Download complete.
So that's
dialog,
the
button.
And it was actually a lot easier than we thought it would be. And what's nice about that workflow is that if you download the Braille equation and then you download the PNG and then you emboss it on the top, and I was actually really surprised because I wasn't sure what to expect on this embosser, but I was really surprised by how crisp and clean it was, especially the graph. But on this first page, it just says expression list, it gives you the name, it gives you the number of the expression, which is number 1, and then it gives you the Nemeth expression, and then right on the next page, you have a full graph of that equation. And so we're really excited to kind of have our students even get to that greater level of independence by having that tool inside their own house, and not only for the logistics of it, to be able to just send them graphs and tactiles, but to also have them set up and having to know how to use that tool, and then already being established with making those choices of what content they think they need, what content they can produce on their own. And so we're really excited to see how that workflow for the student will end up. So it's the first time we're kind of trying this out, but in the next couple of weeks, I think we're gonna see some pretty good results from that. So those are the main workflows that have really worked for us. And one caveat to the Desmos workflow is before you actually start going through that process, and I also put this on the notes too, is that you would want to check out the Desmos accessibility video and section on your specific screen reader, because there are things and adjustments that you have to make depending on whether you're using NVDA, whether you're using JAWS, that has to do with navigation and things like that. But they have it all laid out. So once you know what path that your specific student is taking, then you can make those adjustments, and it makes it really fluid. So that is, I think that's it for those workflows.
Awesome. Thank you, Neal. So I have a question for you, or maybe it's like a two-part question. Do you have any hot tips to share with like your first workflow hot tip for getting teachers trained, classroom teachers trained to do this? And then for your second workflow, do you have any hot tips for getting the students set up to emboss at home?
So for the first workflow, we found out that we first started having these meetings with the student there too, and the teacher. And we found a lot of benefit of having the student chime in, because they would say, oh no, this is how I do it. And it creates that dialogue where I think some of the teachers might be hesitant at first. They might think it's rude, or they might kind of be standoffish to ask how their students are accessing these things. They just don't know. So we found out having meetings with both the teacher and the student, and then we kind of put it on the student. So eventually the teacher had very little questions. They would go to the student to make sure that they maintain that access. And then for the student side of it, just leave enough room for a relaxed transition. Because I think sometimes, and I think that comes from maybe a little bit lack of understanding on maybe some of the support team, they just don't understand the technology. So when we introduce this, it's going to be kind of an extra thing. It's not going to be like, okay, now you have to emboss all your own graphs. You are in charge of this. It's going to be, let's figure this out. Let's get all the troubleshooting out of the way. Let's slowly enter this into your workflow and then see what works. And the beauty of it is eventually that student will be able to take full responsibility and create the workflow, because that's what we love seeing the most. They decide, okay, this is my toolbox, this is what works. And that's kind of the goal of what we do anyways.
Awesome, Neal. Thank you for sharing the extra tips. I especially love how you set up these workflows to empower the blind or low vision student in their own process. And so I love how you described, kind of transitioning that power over to the student so they can direct their learning with the teacher. They can direct, do I want just an audio trace and get a sonification of the graph, or do I want the tactile graphic? Do I want both? And that student can make that educated choice. And I think that ultimately sets them up for success in higher ed, in employment, college, transition, whatever, because we all know that in college, there is no teacher of the visually impaired. And the student actually has to direct all of their own access. And I think this is a perfect segue to turn things over to Shawn Jordison, who is our second presenter of the night. And Shawn is actually coming to us from the higher ed alt media specialist side of things. And so Shawn is an alt media specialist with the California Community College Accessibility Center. Hope I said that correctly. And Shawn is a more recent colleague of mine. I met him because I actually attended one of the CCCS, no, I don't know the acronym, California Community College.
I have the longest business cards on the planet with the job title and then place of work. Yes, we call it the CCAC, California Community College Accessibility Center.
Awesome.
There's
Thank
some tests later, so write that down.
Yeah, we might have to pop quiz that later. So anyways, I was attending a webinar from the Accessibility Center, and I really appreciated what Shawn had to share about digital math accessibility. And so I know Neal, from his presentation, he mentioned LaTex, he mentioned a couple different formatting things. So Shawn has got a little bit more technical background to explain, and then quite another workflow from his experience as an alt media specialist. So thank you, Shawn.
Perfect. Thank you for that introduction. Hello, everyone. My name is Shawn. Nice to meet all of you. Before I get started with chit-chatting away, I do have a 4-year-old and a 3-year-old in the house, and it's very likely they will be on me at some point, but we'll see how that goes. Yeah, so I've been in the accessibility field for about 10 years now. I worked as an alternate media specialist. I was a teacher of students with disabilities at Santa Monica College, and now I help give guidance for the 116 community colleges in California. In addition to that, I do business consulting and work with individuals, faculty, anyone that wants to learn about accessibility. So I like to think I'm a rare breed that brings a lot of institutional knowledge, but I'm good at the human side of it. And so hopefully today you'll leave here with some tools in addition to what Neal had gone over. And Neal, great job. I'll probably be reaching out to you with some tips. This is nice because oftentimes in this world, it's really easy to get one-sided. And so I've actually never used Desmos. In fact, it's been a little while since I've worked with a blind student in my new role. But one of the tasks I've been tasked with is what's a widespread solution for providing accessible documents. Now, when we start talking about math, that often gets very confusing and muddled. And so it's nice to be around some people who know what they're talking about. And I haven't heard some of these acronyms dropped in a long time by people other than me. So with that said, let's jump in here. And I encourage all of you to interrupt me if you have any questions. I talk somewhat fast, but there's a lot of interesting information to cover on this cold Monday night. All right, sharing my screen. So this topic that I created, it's mainly using MS Word, and we're going to walk through how to create an HTML file and an accessible EPUB file. So this is somewhat of a unique type of approach to an accommodation. And this might not work for all students. This may only work for a handful. In my experience, this gives the most amount of frontline work prior to an accommodation. So this is going to check the most amount of boxes before you need to go to the next step, if that makes sense. I hope it will as we move along here. So briefly, we'll be covering LaTeX, MathML, so universal design, creating equations using math type, creating an HTML page, and using this tool called the Word to EPUB plugin. Now, there are a lot of words to describe what's happening in the background. Here's what I'll try to explain in terms of the difference between LaTeX and MathML. Essentially, any math as it's communicated to a computer is encoded. This encoding occurs in multiple areas. The Microsoft Word equation editor uses encoding called OML. LaTeX is a specific type of encoding, and MathML is a specific type of encoding. Now, all three, and there's more, there's binary and several others. These wrappings on the math is what's communicated to our assistive technology. So earlier, Neal, when you said you're not sure what part of it is getting it to work with the Nemeth, I believe the default encoding for Equatio is actually MathML. With that said, I love Equatio as well. This is going to be in addition to that. So it's good to know different applications that can create all of this type of encoding. And there's actually tools that can help convert from one encoding to another, which is pivotal for a lot of assistive technology. So LaTeX, form and typesetting, we have some examples here on the screen. Luckily, you don't have to ever work in LaTeX. I've actually worked with a handful of professors that can write LaTeX, just write it out. I don't know if any of you can do that. I find that to be like a crazy, unique niche skill. I've actually worked with a blind individual who was taking a graphic design course, and the student knew every hex color by heart in different shades of blue and red. It was incredible. Anyways, moving on. So MathML is another type of encoding. The biggest difference is how the math is communicated. And so in a lot of applications, or if you're working in any LMS, are any of you using Canvas LMS or Moodle? I'm not sure what you guys are using. In the community college system, we heavily use Canvas. And what's interesting about it is the editor inserts all of its images, excuse me, all of the math as an image, and then inserts the LaTeX as the alternate text, which, unless you can read LaTeX, can be pretty tricky. So it's just an interesting insight there. Now, the MathML is a different type of encoding, and it looks much different visually. And oftentimes people do not write MathML by hand, whereas with LaTeX, they would in some cases. Now, I have found some information that leans towards MathML as being the more universal design inclined approach. And usually this is because it gives the most amount of options at the end of the accommodation trail. And what's cool about MathML, if I have time, I'll walk through it, is it allows students to orally walk through various parts of an equation, whether that's in HTML or within a Word document, depending on their reader. So how do you create MathML in LaTeX? Well, Neal touched on one of them, which was Equatio, and it's a very, very popular program. Equatio is the day that they can do it automated, the day they will have me as a speaker for them. I've leaned heavily on math type. And the purpose for that is because typically I work with institutions as a whole. And so it's easier and cheaper to get everybody on a single application. And we found that to be easiest with MathHub. So basically, it's very similar to what Neal showed you. There's applications for Google Doc, Microsoft products, most modern LMSs, and it allows you to create both LaTeX and MathML. Now, how do you actually enter an equation into MS Word using math type? Well, I have a direction here because I do presentations in a very specific way, and I like to show how you do it. So essentially, these are the steps. You do have to have math type installed. Basically, you select the math type toolbar. We select inline. A box pops open. You type your equation, and you hit close. So we are going to try that out really quick. And I just want to verify, can you guys see my Word document here? Should be blank. Excellent. I do see a question pop open. Hold on one second. What does math type cost? It depends. I bought it on my own, just personally as an individual, and I think it's $49 a year. if you were to go in with your institution and say get 100 licenses, that price would plummet to a couple dollars a license. It is made by a company. Well, it was acquired. I know way too much about this stuff. It was acquired by Wireless, which is the big one out there. Yeah, I love this tool. So to enter an equation, we're going to select the math type toolbar. We're going to select inline. Now, the reason we select inline is because this is an accessibility best practice. If we chose a different type of formatting, we could have issues down the line. So this is a good base starting point. Now, I don't know math very well. I'm not going to lie. I have an associate's in English and education and all these other degrees, but not in math. So with that said, I'm going to choose a default equation. I don't even pretend to know what this is. Quadratic equation? I think that, or is that this one? I don't know. Who knows? You all probably like, what is this guy talking about? All right, so we have our equation. We can make it larger for one. This is one reason why I like math type. A lot of times it's hard to resize equations. So if you have students with low vision, you can come in here and drag these boxes pretty quick. You can also change the default font size. Now, the next slide in my PowerPoint is how to create an HTML file. So we are going to do that. I like to add in some context first, though. So this is going to be our assignment 1. And Neal, earlier I saw you doing list items. And I used to do that, and I've since pivoted, and I was curious as to your thoughts. I do it all in headings now. So, for example, I'll do question 1 and mark it a heading 2. And I started doing this because oftentimes we would have the solution. If this was like, let's say, a midterm practice or something, we can then mark that also a heading 2 or in heading 3. And it would allow the professor to come in here and then insert their equation or answer to the equation. One thing I also like about math type is you can copy and paste your equations. So if you're working with the same formula over and over, you can simply come in here and change a couple of the variables. And so all of this, there's no rule on this, especially everyone knows this. You've been working in this environment. It's all about staying consistent, in my opinion. So however you choose to do it that way over and over. Okay, so we have our heading 1 in here. Let's put in some directions. Please solve the following equations. All right, now we have a pretty decent looking assignment here, right? We could expand this out to 20 questions or so. Anyways, let's go to math type. And here's where we're going to create an HTML page. So this is going to have accessible math in an HTML page that can be read with basically any screen reader. And I believe it also works with VoiceOver on iOS. So this is more of for a screen reader style. So with that said, we're going to select the math type toolbar. Then we're going to select publish to math page. It's going to force us to save our document. Let's try that again. All right. So we have our math file. We have our publish to math page options. Now here's where you can choose where this content's going to live. I'm going to throw this on the desktop really quick. Now there's a key step here, and it's in my PowerPoint presentation, which I will share with Ting. Essentially, we have to choose MathML using HTML and Mathjax. This is very important. If we don't choose this option, it's not going to be accessible with all the screen readers. It may only work with 1 or 2. I heard a munchkin yelling for me. Hold on 1 second, you guys. I'm just going to quickly mute myself.
Okay, maybe I will take this opportunity to ask a question, actually, buy you some time. So, Neal, first question for you is you were demoing how to put an Equatio equation or screen grab an equation from Equatio into Microsoft Word. If a teacher were to then plop that Word document into Google Drive, would they need to maintain it in that Microsoft Word file format in order for it to work?
I think I'm not sure I understand your question completely, but like, you mean, like, would they be able to see it on the preview if you sent them that document? With
Or
the,
how would you share that Microsoft Word? I mean, it would have to be retained.
Okay, no, that's
right.
a great question, and I put that in my notes, but I forgot to mention that. So at first, we were sending these documents that we made accessible to the student and the teacher. The student had no problem opening it because they're opening it on their device, which would be close to a Microsoft Word editor. The teacher was opening it, and it was just on the web preview. None of the equations show up there. You have to download it first and then open it through Microsoft Word in order to actually see the content. So that's a very good question, because at first he thought he was doing it wrong, but he just wasn't downloading it completely and opening it through Microsoft Word.
Okay, and you definitely could not open it as a Google Doc, correct?
I don't remember if we tried that or not.
You would have to do open with, and it might work. Like if you have the exe of the Google Doc, you know how you can create shortcuts for Google Drive documents on your desktop, but you have to like code it a little bit different. Because natively it wants to open it in your Chrome or Internet Explorer. But you can set it up to default to open to that. I haven't tested exactly what you guys are talking about, but yeah, that's a good point. And so within Canvas, that was a big thing, which is a learning management system. The preview would throw everybody off because they would see it, they can scroll through it, they can click it, select it. I use the analogy, it's like window shopping. So you see a nice jacket through the window, you know, you can tap on the glass, but you can't quite get in there. You actually have to go in the store, right, to try on your jacket. You have to download your file, which is your jacket, before you can do anything with it. And that's been a common thing that I've seen. Thank you. With that said, I'm going to transition back into here. Is that okay? Okay. So I want to get through one more of these workflows here. So we're going to choose HTML and Mathjax. Now this basically adds a line of code to our HTML file. So if you're comfortable working in HTML, or maybe you use another editor, we actually have a line of code that you can insert, which will activate the Mathjax so long as your math is properly embedded. MathType kind of does it all for you. So we're going to choose this option, HTML and Mathjax, select OK. And now it opened up our document. What's nice about this is the zoom is set really nice. I worked with a lot of low vision students when I was at Santa Monica College, some of which we would have to do large print in 60-point font because they were not comfortable with technology. And so it was just one of those things. Okay, like, let's do it. And so we all got real comfortable with sizing these equations. Now, I'm not going to run JAWS in the background. I'm going to assume you all are somewhat familiar with what a screen reader does. Essentially, in this particular example, we could come in here and actually walk through our math equation. Let's see if we can get in here. Is it the Explorer? There's a rule of thumb. Never try anything new during a presentation and look at me. Breaking the rules Monday night. Oh. Okay. Well, if I was running JAWS, I can get into that equation and it would highlight the individual pieces of it. And we could tap our arrow key and it would say, you know, the first part of the equation versus the second. And this is really nice if you're doing a demo of solving an equation, right? Where we might have You can do a similar header structure where we would do step 1 of solving this equation, and you would do the pieces, right? And a textual description. And you could do that multiple levels down, and the student would be able to navigate every one of those. Now, again, this file can be uploaded to an LMS. It could be shared with students, and it could be interacted with just about every assistive technology, including this should work with refreshable braille displays as well, because the math is formatted as MathML. So this is one use case for creating accessible files with math in it. Now, if we didn't go to that step, looks like we have some equations missing. Interesting. I was going to say that this gives you the best starting point if you were going anywhere else as well. But as we can see, Murphy's Law is taking over here. And I have some random picture on my document. That's okay. We're going to start a new document and go into our next workflow. So we saw how to create HTML file. Next up, we're going to talk about creating an EPUB. And so create an EPUB. How many of you have worked with EPUBs? Guessing not many of you. So EPUB is a unique file type. It's unique in the sense that it's semi-new to the publishing world. You may think of Kindles when you hear EPUB. That was the major platform for a long time. Yeah. And the Kindle Fires, like, don't even say that in the accessibility community. They were terribly inaccessible. But EPUBs themselves offer a unique experience. So EPUB files have a lot of structure in their document. They are similar to DAISY files, if you've ever worked with DAISY, and essentially gives your file a unique reading experience that allows content to be flowed seamlessly from one page to another. Now, for a long time, it was challenging to get math into an EPUB. And the reason, I skipped one step, the reason for EPUB is because it works on any device. That was always the draw from the community college standpoint, is what can be created once and used the most amount of times. And EPUB fit that bill to a certain extent. So it could be used on any mobile device, any computer application. And as of late, the Thorium Reader is a fully accessible EPUB reader. So it works with all the modern screen readers. And so that's why we have so many documents here, so many software applications. With that said, I'm going to keep going here. So in order to create an accessible EPUB file, we have to create equations using the Word equation editor. So not math type, not Equatio. This has to be done the old school way within MS Word. Now, you might be thinking, Shawn, does that mean I have to recreate all my equations? And the answer is no. There's another program called GrindEQ that can transfer our MathML, our LaTex, and turn it into OML. All right, getting too far in the weeds there. Let's just practice this. So let's create an EPUB file. First things first, we need to have a heading. That's the most important part of this. So we're going to just create a generic heading 1, and then let's insert some math. So we go to insert, and over here on the far right, we have equation. And let's take the quadratic formula. And I'm going to left align it. All right. So this equation can now be converted into an EPUB. And the reason why this may save you a lot of steps, if you have a student who uses JAWS, this might be a preferred format. They just might not know it yet. So if you have multiple problems in here, we can use the Word to EPUB toolbar. This is a free application by Daisy that will simply translate this document and create an EPUB. You have to save your file first. I apparently can't ever remember that. Then we do Word to EPUB. We can choose all of our metadata, which is translated to the assistive technology. I'm going to leave the default for now, and then we'll select our math. We can actually choose the type of encoding. So we have MathML, or this is the most common type you'll see, is your equations get inserted as an image with LaTeX alt text. I prefer the MathML, but technically both of these will pass any accessibility standard. So we select OK. And all right, so this is Thorium. Obviously, there's not enough time to talk about this. So we have Word. We have the Word to EPUB toolbar, which will create an EPUB. And then Thorium is an accessible EPUB reader that works with JAWS or NVDA. And it also has its own built-in text-to-speech reader. However, it's not going to work with our MathML. You would want to use JAWS in here. But essentially, this content could be loaded onto any device. You can change your font size, your display, either scrollable or paginated. You can choose your spacing, how the MathML is encoded, how the read aloud information is there. And we have another accessible format from a single Word document. So that's Word to EPUB. There's a lot more applications that can help translate your math. There's a program called Empty Reader that can convert multiple pages of math simultaneously. Again, we have our Word to EPUB toolbar, and then Grind EQ will take you from those different encoding types. So I'm sure this was a tsunami of information. That's okay. The important part is for you to understand, get that math in a Word document, and then we can do anything to it. The end.
Thank you, Shawn. That was a tsunami of information.
Yeah.
I was thinking with your EPUB workflow, that might be a good way, like if somebody had to prepare a workbook or something for students, to have it in like a digital book format.
Totally.
And then what might be some use cases for putting math into that HTML format?
So from my experience, you want to have the biggest toolbox possible. There have been specific cases that students preferred JAWS, and for whatever reason, it worked better to do the HTML files versus the Word files. It really depends on what the student wants, which is the case with everything that we do, right? You might be preparing tactile graphics for one and refreshable Braille display for the other. And I know many blind individuals who do not read Braille. And so in those cases, these situations are going to be better. So it's hard to pinpoint. It's important to know the tools in the toolbox. So it depends on their application at home. I've met homeless blind individuals, and sometimes a certain file type works better for their older device, like on iPhone and iOS, right? That HTML file might work better than a Word document because they don't have a computer. So little nuances like that.
Okay, awesome. Thank you for the answer. I think it just reminds all of us that there's no one way to do anything. Just like there's no one way that we can expect students to access their information at all times. So you guys, we have 3 minutes left. Does anybody here want to ask a question?
Who needs a eggnog?
Neil, is that a hand for eggnog or a question?
Eggnog.
Is it okay to share my email if there's any questions?
Oh yeah, for sure.
Is that okay?
Yeah.
Okay. Sometimes I'm not allowed to. This is my personal email address. You guys can reach out to me at any time for questions, and I'm happy to respond. I answer lots of faculty questions, and Thorium is free. That's another kicker. It's a free, accessible EPUB reader.
And I mean, we know that there are a lot of other EPUB reader apps too. So, I mean, I think if you're not sure about Thorium, my recommendation would probably be to like play with different reading apps and how they handle the EPUB with math.
The big one, Thorium's the best with math. That's why the other ones oftentimes can't display it properly.
I was wondering about that.
Yeah.
iBooks. Can iBooks handle math?
I think it has to be encoded a certain way. I honestly haven't tested it specifically.
Okay.
Yeah.
Cool. So it might be that if a student's reading like a math ebook, they might use Thorium, but then for their literary text, they might still continue to use
Bingo.
Reader or something like that.
Bingo. Yeah.
Okay. Cool. Awesome. Well, we are just about at time. Shawn, thank you so much for sharing your expertise with us and your email, for welcoming people to contact you. I saw, Shawn, that you have a Twitter handle, but I don't know how active you are on it. And I know, Neal, you are definitely active on it. So Shawn, did you want to put a plug for any social media contact for you?
I'm out there under my name. I don't really, I tried and you'll see lots of like, what is he posting? And it's probably useless, but I am connected. So I've been seeing the tweets and stuff, and yeah, I just don't use it that often. But if you need to contact me, you're more than welcome to do that as well. I also have a website, shawnjordison.com. It's going to encourage you to buy stuff, but you don't have to. So.
And then Neal, you want to share your social media stuff?
Yeah, I think the one I'm most active on is Twitter, which is @Neal_AT.
Great. And Neal spelled NEAL_AT. Thank you. And then Neal, we're going to share the link to your tactile teaching aids, your Google site that you created.
Cool.
And I don't know why, whenever I go to Tinkercad and search Wonka face, WONKFACE, I'm still not seeing your 3D prints, but is that your printer?
I know I tried it yesterday and it wasn't working. I got to fix that.
Okay,
see what's
so
going on with that.
3D files for 3D printing are on Tinkercad. I guess to be figured out shortly, hopefully.
Yeah.
So.
I was going to mention one more thing. I think it was you touched on it in the beginning. I think it's a real exciting time to be in this field, because I do believe we're at that last point to where we are figuring out these workflows, but it'll be nice when we get to the point where all these are integrated, where you can get the audio, you can get the refreshable braille, you can get everything streamlined. And I feel like we're closer than we've ever been to that. So it's pretty exciting to be in this field right now.
Yeah, and just if we could make one last plug for companies that are doing the right thing and really thinking about accessibility from the initial step of design. I mean, like Desmos is just outstanding for that reason. And Equatio is helping to close that gap. So yeah, we're so grateful. Well,
Thank you for having me.
Thank you so much, Shawn. You're officially like part of our special people with the VI program now.
Oh, it's awesome. Yeah. I love it. I appreciate the invite.
It's a good group.
Yeah, thanks, Dan. Hopefully we will have a chance to hear from you again.
Of course, anytime.
All right, you guys. Well, I think that's it for Note 8. So thanks everybody for joining. Thank you to our presenters. Thank you for Francis Dibble, our dear intern supervisor, and all of you guys making time for this tonight. So we'll see you next time.
Thank you, Ting. Night.
Hey, good night, guys. Bye.
Thank you.
Thank you.
Hosted by Yuting Su, PhD, VI Program Coordinator and Assistant Professor. Video editing by Monica Kulanai, VI Program Manager.